Alright class, today we're going to be talking about similar solids. Similar solids are solids that are the same shape and they have corresponding dimensions that are proportional. Just like with similar polygons, the sides are proportional, here our corresponding dimensions are proportional. Okay? The scale factor is the common ratio of the corresponding linear measures, such as radius or height. Alright, so let's look at these two cylinders that we have down here and let's decide if they are similar or not. First, let's find the ratio of their radii and see if that is the same as the ratio of their height. Okay, to see if they have the same scale factor. The radius of this red cylinder is 9. And the radius of this blue cylinder is 12, so it's going to be 9 over 12. Now that can reduce down to 3 over 4. Alright, now let's find the ratio of our heights. The height of the red cylinder is 15, and the height of the blue cylinder is 20. So it's going to be 15 over 20, but that also reduces down to 3 over 4. They have the same ratio, which means that these are similar and that our scale factor is 3 to 4. Alright, let's go down and fill in this chart down here. There are 3 characteristics involved with solids, and they are length, surface area, and volume. We're going to talk about how many dimensions each of those have and their corresponding ratios. So, length is just the height or just the radius or just a length, and that is just one-dimensional. It's just one dimension. Okay, surface area that we've been talking about, that has 2 dimensions. That's why we square the units. And volume has 3 dimensions, and that is why we cube our units. Okay, volume has a length, a width, and a height. That is why it is 3 dimensions. So if we have a ratio for our lengths of A to B, the ratio of our surface area is going to be A squared to B squared. And the ratio of our volume is going to be A cubed to B cubed. Notice how the ratios correspond to the dimensions. Surface area has 2 dimensions and we square the ratio. The volume has 3 dimensions and we cube the ratio. So let's go up here and look at our cylinder and let's find the ratios for each of these. We know that the ratio of our length or our radii is 3 to 4. So our ratio is going to be 3 to 4 for its length. Now we need to square that ratio to find the surface area. So that's going to be 9 to 16. And we need to cube that first ratio to find the ratio of our volumes. That's going to be 27 to 64. And those are the 3 ratios for our cylinders up above. All right, let's go ahead and do some example problems. In this first example, we have 2 similar prisms, F and G, and they have a scale factor of 1 to 3. We want to find the surface area and the volume of the big prism G, given the surface area of prism F is 24 square feet and the volume of prism F is 7 cubic feet. The first thing I'm going to do is write down our different ratios. Okay? The first thing I need is the ratio for the length, and they have given me that equals 1 over 3. I then need the ratio for surface area, and we know that we have to square the scale factor. So our new ratio for the surface area is going to be 1 squared over 3 squared, which is really just 1 over 9. The last ratio that we need is the volume ratio, and we know that we need to cube the original scale factor. So that's going to be 1 cubed over 3 cubed, which is actually 1 over 27. So we now have our 3 ratios, and we can set up a proportion to find our surface area and volume for prism G. All right, let's first start with surface area. I know that the ratio for surface area is 1 over 9, and that needs to equal the surface area of F over the surface area of G. So the surface area of F, they tell me, is 24 square feet, and I am looking for the surface area of G. I'm going to call that X. We know to solve proportions, we have to cross multiply. So if we cross multiply here, we get X equals, let's see, we plug that into our calculator and you get 216 feet squared. Make sure it's squared because it is surface area. Now let's do volume. Over here we're going to do volume. We know the ratio for volume is 1/27, and that has to equal the volume of F over the volume of G. So the volume of F is 7 cubic feet, and we are looking for, let's call it Y this time, the volume of G. I'm going to cross multiply, and I'm going to get Y equals 189 feet cubed. Make sure it's cubed because it is a volume. That is the volume for prism G. All right, let's go down to example 2, where they tell me that two spheres have volumes of 16 centimeters cubed and 128 centimeters cubed. The larger sphere has a surface area of 72 centimeters squared, and we want to find the surface area of the smaller sphere. Once again, the first thing that I'm going to do is set up my ratios. I know I'm going to need the length ratio, I'm going to need the surface area ratio, and the volume ratio. Now they have given me the two volumes, so I can find a ratio using that. It's going to be 16 over 128. Now if you reduce that, you divide 16 by 16 and you get 1. You divide 128 by 16 and you get 8. So our ratio for our volume is 1/8. Now we know that in order to get to the volume, we had to cube the length ratio. So in order to get back to the length ratio, we are going to cube root the volume ratio. Okay? So we need to take the cube root of 1, and we need to take the cube root of 8. Well, the cube root of 1 is just going to be 1. So that's going to be our top of our ratio for length. And we can find out that the cube root of 8 is actually 2. So that's going to be the bottom of our ratio. So our length ratio is 1:2. Now to find the surface area ratio, we need to square that. So that's going to be 1 squared over 2 squared, which is really 1 over, oh wait, that should be a squared. Sorry, it should be 2 squared. Okay, so that's 1/4. All right, now we have all of our ratios, and now we can set up a proportion. We are looking for surface area of the smaller sphere. So we're going to find surface area. We know our ratio is 1/4, and that has to equal the surface area of the smaller sphere, which was what I'm looking for, over the surface area of the larger sphere, which is 72. We need to cross multiply, and we're going to get 4x equals 72. We divide both sides by 4 to get x equals 18 centimeters squared, because this is a surface area. That's our final answer, and we are done with video notes for similar solids. If you have any questions, feel free to email me or come by for tutorials.